Okay, in this video, we're going to talk about how to wire the breadboard for the top of the robot. This is a picture of what the breadboard looks like, and I'm going to show you how to breadboard this. Now, typically, whenever I breadboard, I usually start with the components and specifically the most complicated component on the breadboard, and that is the microcontroller, this blue chip here in the center. Now, and then as I work my way out, I start connecting power and ground to the circuit. And then I start hooking up my components um, that you see on here, like the LEDs and the infrared receiver and capacitors and resistors. What I'm going to do, though, instead is first we're going to talk about the wiring diagram that you see right here. And I'm going to tell you about how to exactly place the wires on the breadboard. Now, if you look at the breadboard, what you'll see a number of columns right along in here. And so it has columns A, B, C, and D, and E, and then F, G, H, I, and J. And then you have a number of rows, 1 through 30. And so each hole has its own address, which is a particular column and a particular row. So therefore, if I say A1, I'm talking about this first hole right next to the A and the 1. And I'm going to be using this coordinate system to kind of tell you exactly which hole to place these wires in. The reason why I've done it this way is I've actually redesigned this circuit about 3 or 4 times for optimum component placement so that the breadboard looks nice and it's easy to wire. And then when we're also dealing with the sensors like the infrared LEDs and the infrared receivers, they have to be a specific place and they have to be positioned properly in order for them to work. And then also there's not a whole lot of room on the breadboard, so where these components are placed ensures that we have enough room for all of the components on the breadboard, and also leave a little bit of room because what I've actually done is I'm actually having some ideas to put some add-ons onto this robot in order to do additional sensors and servos. So that's why I've placed the LEDs where you see, or why I've placed the wires where you see them right now. Some of the things that you'll need for this project are tools. You'll actually need, the first tool that you see right here is the diagonal cutters, and that's for cutting any wires that you might have. The second tool are the needle nose pliers. It's because they have this long nose tip right here. And then we also have some wire cutters, which we use in quite a great deal. Usually if you have a wiring kit and you don't have specific lengths of wire and you need to cut your wire, we would use this more. And then finally we have a pin that we'll use to, maybe we need to mark the wire to cut it a certain way or to bend it. And then also it's used for when we look at our schematic, which is a schematic for the diagram. Usually when I'm wiring this and I'm putting the wires in, I usually place a mark on the component with my pen as I go along. And so these are the tools that you'll need for this particular wiring exercise. The wires that you'll need are 8 orange wires, 6 yellow ones, 2 green ones, 1 red wire, 1 blue wire, 1 purple wire, and 1 brown wire. Now, why are we using all these different color wires? Well, for one thing, if you'll notice, all of these are different lengths. And if you look at the wiring diagram here, these lengths of wires have certain links to them that skip a certain number of wires. For example, if you look at the orange wires, you notice that the orange wires have 2 rows in the center of them. If you look on A3 through 6, you notice that there's 2 rows in between 3 and 6. And so that orange wire jumps those 2 rows. A yellow wire jumps 3 rows, and a green wire jumps 4, and so on. So I used those colored wires so that they were already pre-cut that came in the kit, so I didn't have to cut my own wires that way. And that's why I used those different lengths of wires. Another thing that you're going to need is all of the wiring, or all the components to wire them. The first thing that we're going to do is we're actually going to put the wires in the breadboard, and then we're going to add the components to where this should be what the finished breadboard looks like once all the wires and the components are in. These components should include your microcontroller, the Arduino Nano version 3. You should have 3 220 ohm resistors. You should have a slide switch. You should have a capacitor. You should have 2 infrared receivers, 2 infrared LEDs. You should need a regular red LED, and then you should need 2 kilo ohm resistors. On top of that, you're also going to need what they call male-to-male headers. These are going to go in between your battery components. The one with 2 leads are going to hook up your battery box to the breadboard, and then the 2 3-pin headers are going to go between your servos and the breadboard. Now these things right over here are what I call the LED cap and sheath. And your LED is actually going to fit into here, and then that cap's going to go over the sheath, and it's going to keep the LED inserted into the sheath, and you're going to use that to mount it on the board. And what that's going to do is that's going to keep the infrared light from the LED from directly making contact with the infrared receiver. This is going to make it actually bounce off an object, and it's going to have to reflect off an object before the infrared receiver picks it up. And so that's kind of an introduction. You can find this schematic that tells you exactly how to wire the breadboard if you want to do it the old-fashioned way, where you start with the components and you wire it up. You want a little bit more challenge to the project instead of finding out exactly where each wire goes. You can use the schematic, and you can download this off the website. In the next video, I'm actually going to have the camera, and you're actually going to see me hooking the wires up into the breadboard.